Okay, so we're gonna do, I wanna do a proof.
Oh.
Yeah, I was joking with another teacher. I said, whenever I prove something, whenever you teach a math class like calculus or something, you say, I want to do a proof, you could hear a collective sigh. And it's funny because now I have it on video where I said proof and you guys went, well, it's not like a geometry proof. You guys have probably only been exposed to geometry proof. I did some last year for pre-calc. I just didn't tell you guys I was doing proofs. I just made it seem like I was doing a problem. But basically, this is the power rule, okay? And so the proof is we're going to let P and Q be integers. Where Q is greater than 0. And we're gonna suppose that y is equal to the q root of xp, which is really x is raised to the p over q, right? You guys remember all that stuff?
Yeah.
So now if that's the case, what we could do is we have y is equal to xp over q. Now mathematically what I could do, if I multiply this whole thing, if I raise it to the q, I get y to the q is equal to x to the p. Does that make sense?
Yeah.
Okay. And so what I want to do then is, since p and q are integers for which we already have a power rule, we could differentiate both sides of the equation with respect to x to obtain the following. So if I take the derivative of this using the power rule, I toss the q to the front, and I have y, and now I have q to the -1 up here using the power rule. But now this is the derivative of y with respect to x, and that's equal to p, now we're taking the derivative of the right-hand side, p times x raised to the p minus 1. I'll leave that there for a second. Does anybody have any questions? Do you see what I'm doing so far? We're doing implicit differentiation. So now to get dy dx by itself, I say that dy dx is equal to, I'm just going to divide both sides by all this stuff, right? I'm going to divide both sides by that. And so that should yield p times x raised to the p minus 1 all over q times y raised to the q minus 1. Okay? All right, well, now what I could do is I could say dy dx is equal to p over q times x raised to the p minus 1 over y raised to the q minus 1. But wait a minute. What is y? Well, we said way back here that y was equal to x raised to the p q. So I'm going to replace this with x raised to the p divided by q raised to that. Well, let me write it a little bigger. It's a little smaller there. So if I replace the y with x raised to the pq, that's going to be raised to the q minus 1. Do you guys see where that comes from? I'm just replacing this y with x to the p over q.
Wait, I don't even understand what you're replacing.
Well, it's part of the proof. What I'm trying to do is prove the power rule. Okay? for rational powers. So we know the power rule for integers, but we want to see if it works for rational powers as well. Rational powers is like a fraction. So will the power rule work if I say x raised to the 2/3? Well, we're trying to prove that. And one way that we prove that is symbolically. We use a bunch of variables to represent numbers, and if I can make it look a certain way, in other words, what I want to do is I want to kind of prove this. I want to prove that this will work if n is less than 1, if it's a fraction. Okay? So that's what we're trying to prove. So what I'm trying to do is I'm trying to figure out what y prime is, and hopefully, because I'm using a bunch of fractions, maybe it'll work out and show something that looks similar to this. Does that make sense? All right, so what we're going to do next is well, here's the thing. Now I have the same base, and so to build on the question that you asked, because these are both have a base of x, I could do some fancy stuff. So let me just do one more thing real quick. This is p to the -1. Now, when I raise a power to this, what do I normally do? I normally multiply this times this, don't I?
Yes.
So when I do that, I got p over q times q minus 1. Now in the next line, your textbook skips this line. I'm not going to because I want you to kind of see what we're doing. P times q, in other words, if I expand this out, and I'll write this over to the side, P over Q times the quantity Q minus 1 is going to be PQ over Q minus P over Q. But these Q's cancel, right? So then this becomes X raised to the P minus P over Q. But now what can I do? If I want to move this up to the top, how do I move this up to the top? I subtract this from the top. Right? Do you remember that? If I have x to the m and x to the n, isn't that the same as x to the m minus n?
Oh, yeah.
Does that make sense? So now I've got P over Q times X times P minus 1 minus P minus P over Q. Now see, my goal is I want it to look sort of like this. Are we getting there? Is it starting to look like it? Slowly but surely, right? All right, so now I've just got to do some algebra on that right there. And what happens when I distribute the -1 through, this becomes negative P, and this becomes positive PQ. All right, and so now we're just kind of adding them up. Well, what happens there, if I factor out, I end up, really, what I end up with is P over Q is multiplied by X raised to the P over Q minus 1. So that's the power rule, identical. So in other words, what they're saying is I've just proven the power rule will work for any power less than 1. Does that make sense?
Yes.
Does anybody have any questions? No. Okay.
Oh.